So looking at the derivative of arcsin function, I'm going to go through how you can actually figure that out without knowing it. And it's just manipulating this equation. So if you look at the arcsine of 4x is equal to y, if you took the sine of both sides, you'd have the sine of y equals the sine of the arcsine of 4x. Now, using the inverse relationship, we know that that is going to end up being sine of y is equal to 4x. So from here we can derive this now using implicit differentiation. So we get the cosine of y dy dx is equal to 4. So we're going to be able to get dy dx is equal to 4 over the cosine of y. And now it's perfectly fine to have as a derivative. In order to evaluate this derivative, we would need to know the y value, which is not typical when we have a function written as a function of x. So what we can do is we can rewrite this. So what we have in the way is cosine of y. So when we look at the problem, there was actually a relationship that we had over here in sine of y equals 4x. If we use this in SOHCAHTOA and draw a right triangle, and we use our reference angle as y, sine used in SOHCAHTOA is my opposite to my hypotenuse, which would be 1. So here I have the triangle drawn for that relationship, and then I can use Pythagorean theorem to solve an expression for this side of the unknown triangle. So if we had that unknown side squared plus that expression 4x squared equals 1 squared, I can rearrange this to solve for this, and I'm going to end up getting that this side is going to be the square root of 1 minus the 4x squared. So that's how I have this relationship. So when I look at cosine of y used in SOHCAHTOA tells me to use the adjacent to the hypotenuse. It's the ratio of those two sides. So the adjacent side is the square root of 1 minus 4x, that quantity 4x squared, all over 1. So I can rewrite this as 4 over the square root of 1 minus and then 4x, that quantity squared. That's what we have as our derivative with respect with respect to x, but using just x in the problem. So this would be what you would typically see on the AP exam in terms of the derivative function. Now if we take this same problem and if I were to say, okay, let's just change this for a second. And if I change this into, instead of a 4x, I could change it into y equals arcsine of whatever, 9x. Think about what's going to change in the problem. So I have, this would be a 9x here, this would be a 9x here, this would be a 9, this would be a 9 instead of a 4, this would be a 9, this would be a 9x squared here. So if we look at what we started with and what we ended with in both examples, then if u is some differentiable function, then the derivative of the arcsine is going to be u prime over the square root of 1 minus that u, that argument squared. And that's the rule for the derivative of the arcsine that you typically would see on the AP exam. Either format works technically, but that's kind of the standard way of doing it. But that's where it comes from. And you can do that with all of the inverse trig functions.